yeah, and responsible systems. And just helping the sales guy go through like an RFP. It's just like the questions they ask, the way they operate.
All right, let's go ahead and get started.
Like, oh no.
Good afternoon, everyone. Thank you for being here for the lunch and learn. I hope you guys were able to grab some lunch before the event here. We have a great speaker, Sanjay Kumar, here with us, who's an AI practitioner, and he's going to talk to us about the artificial intelligence. Overall, how it's used in different industries, what it means. So it's going to be a pretty good and engaging session. A quick introduction of the speaker itself. So Sanjay he himself is an AI practitioner today. He's the CEO of Analytica in Analytica. That's also the chief data scientist there. As a firm, they have helped a lot of good Fortune 500 companies, Walmart, PepsiCo, Johnson & Johnson, AbbVie, and Cummins through their AI journey. He was also the senior director in AI and machine learning at Mylan. Mylan is the largest generic drug maker. Again, they've implemented best practices to leverage AI across multiple business units. Sanjay is a Kellogg alum as well. He graduated in 2010. And I believe it's the first time he's coming back to campus, trying to help his fellow Kellogg students help with their quest. So let's welcome Sanjay and
thanks everyone for joining this lunch and learn session. Hopefully you guys will have some takeaway from this 15-minute session. So let me start. So what I'm going to talk about is, I'm going to talk about a little bit my background, which is already covered by Nikhil. Then I will give you an introduction of AI, what is AI, some of the algorithm. Then I have crafted 3 case studies from different industries. And finally, what Kellogg students should do to get into AI, which is already exploding in multiple ways. So let me skip this slide. So let's talk about AI, how it is impacting the human life, right? So let's start from with the help of AI, NASA is able to find a new planet called Kepler 90I, and it was not possible earlier because this planet is located far, far away, and the signals they were getting is very, very weak. So with the help of AI, and Google also worked on this project, they were able to detect a new planet. Then the second application is what we call AI is getting much more smarter every day. And what it means it is able to beat AlphaGo champion called KG. So just to think in terms of AlphaGo, which is considered a very, very difficult game to beat. So because of its becoming intelligence, much more intelligence, it is able to beat human. And this is what is scaring probably a lot of industry specialists and a lot of people, like what we'll do as a human when AI will become so smart. So now, next is a couple of applications like in healthcare, which is very, very closer to my heart. So using AI, machine can detect computer cancer cells. And these are the cells which is possibly not, even human eye cannot detect. So what it means AI is getting better than human. Then on the right hand side, you can leverage AI to detect cardiovascular disease using taking picture of retina of your eye. So earlier, if you have to go and test whether you have cardiovascular problem or not, you have to give the blood sample. So maybe for developed world, these kind of applications might not be very useful, but think from the developing world point of view, where there is a shortage of doctor, nurses, and hospital infrastructure. These kind of applications will be very, very powerful to serve to make the life of people there better. So let's start with what is artificial intelligence. So in my opinion, this is an intelligent system or machine that can act or behave like a human. So what are key components of AI? So you have some techniques which you consider machine learning, deep learning. Then a lot of work is being done in the computer vision area, which is image recognition, object detection, image similarity, and then you have language modeling. For example, what you write, what you speak, that is called language, right? How computer can understand the language, how it can generate the language, or generate what is from some picture you can generate something, and then how you can process to make it more useful. Then finally you have speech, which is conversion from speech to text, text to speech. So if you guys are aware about machine learning, so there are three kinds of learnings are there. Something called supervised learning, unsupervised learning, and reinforcement learning. So what do you mean by supervised learning? I think you guys might have taken the tech classes, right? Those who have taken the basic tech classes. We do a lot of regression and classification kind of problems. So what it means we give some historical data that helps computer to understand some signals, and based on that, when you feed the new information, it will give you output whether this is good or bad or not. So basically, best example is email spam, that it gets trained over the time, and then it detects whatever the keywords are there. Using that, you can detect whether a new email is spam or not. Then you come to unsupervised learning. What do you mean by unsupervised learning is, you don't know you don't have historical information or historical data, right? For example, you have customer information and you want to split the customer into what you call the technical segments. So you can have multiple segments. So here you are not using the prior information, and you are using only what is the given at the moment. And then we have reinforcement learning. I'm going to talk in a little bit more detail about reinforcement learning down the line, because this is a very, very latest technology. So if you look from the algorithm and technique point of view, so you have here, those are the algorithms. So probably those who have taken the tech classes, they might have know about regression, classification, basic stats, Tech 4.3, during our time, Tech 4.30 or 4.31, these things were there. But these are the basic techniques. But if you go to the more right-hand side, which is more advanced technique, and those techniques are being used in artificial intelligence. So some of the techniques called deep learning, which is feed-forward network, CNN, RNN, and then you have transfer learning and reinforcement learning. So I'm going to talk about the algorithm which is mentioned on the right-hand side, on the top right-hand side. So let's start about basic. The core of AI is neural network. So what is neural network? Neural network, in AI, researchers are trying to simulate the way our brain functions. So in our brain is made of millions and billions of neurons, and these neurons are either 0 or 1. It means if either they will process the information or they will not process the information. So here you have input here, and you multiply input with something called weight vector, and then you add a bias to it, and then pass to a function which is sigmoid function. So output of sigmoid function is 0 and 1. It means neuron will either process the information or it will lose the information. And then if you have to create the large neural network, which is called the multi-layer deep hidden you use millions and millions of these neurons, and these neurons are connected with each other, and that help to process the image, the large set of information like images, text, what is now becoming AI, artificial intelligence. So anyone has any question? Okay, so next is what we call the deep convolutional neural network. So just I talked about the neurons, right? So now if we have to process the image and you give the input of image and say like you have to detect which class this image belongs to. For example, you give an image of cat, dogs, you might have heard about. So how computer is able to identify whether the given image is a cat or dog or something else, right? So this is called deep convolutional neural network. So what do you mean? How many of you guys know convolution? What it means?
It's just super complex.
Basic math? No, they are basic math. Right? Okay. So convolution means okay, so this part of the image, it talks about convolution. So what it means? You take a big image, okay, and you put a small filter, say like 3x3 filter, and you slide that small filter image, which is here, over this bigger image, which is say like 224 by 224, and get the max value according to like what is the best feature, right? So that's, you see here -8, this is what it means. So it's being slide over the entire image and then get the best out of that, right? So this is called convolution. And you do same thing on the entire image set but on the multiple layers. So the way convolution works is you take the input, which is this one big image, and apply convolution to this image, and then you'll get like this is called 64. It means the size of the image is 224 by 224 in 64. So 64 is the number of channels. So if you feed this image, which is color image, it has normally 3 channels, right? So what you are doing, basically what you are doing here is, you are taking the information and extracting the relevant information, what is available during that particular process. So basically you got best out of this image using the convolution, and you apply same process on the multi-layer. That's why this is called multi-layer deep neural network. And then finally, once you come here, so you have to basically again go back to the here like multi-layer approach, and then it will identify whether this image is a cat or dog. Just too much for you guys, or it's okay? Okay, so what are some of the application of CNN? So you guys, I don't know whether you guys have seen, now if you want to search a similar kind of clothes or shoes or whatnot, you just upload the picture and it will give you, okay, you can buy the similar kind of clothes from this store or wherever you are. So, and then the face recognition has become a big thing, and it's the future of identity, right? And I think it's coming along, and I think a lot of airlines are even also trying to implement this face recognition to detect who are you, right? So the science behind face recognition is artificial intelligence. Like you can detect whether there's mom, dad, or kids or not. And just to think from the marketer point of view, how they can utilize this information to send you more ads. Anybody? So just to think, like, we love taking picture and uploading on, yeah.
So if I see all of a sudden, let's say Facebook has historical data. If I see a new infant showing up in the photos, they can start promoting beauty products.
Yeah, here we go, right? Yeah, this is the basic, this is what Facebook is doing, right? Facebook or Google is doing. So they are able to detect what's in the picture. And this was not possible before AI or before innovation of this CNN, right? And then you can see like a emotion detection. So how this is important from marketer point of view, right? So you guys go to mall. Now less people go to mall, but still some people go, right? And you have your billboard, and in their billboard there is a camera, and they will detect your face, and they want to understand your response, how you are responding to my ad, because when they create the creative, a lot of science and money goes behind that. So it is helping marketer to understand what kind of ad I should put in place, and how should you target, and whom should you target, right? These are the applications are there. So anybody has any question?
I had a question on the previous slide where you referred to the channels. I'm just curious how the number of channels increase as we go deeper down the network. On the previous slide where you had channels, so the number of channels are going up as we go further down the network. So how is that increase happening?
Because see, you are applying the filters, right? This is the filter. So it's not like only one filter you are applying. You are applying say like 30 filters or 64 filters, and then you are extracting what is the most important or relevant information you have. That's how it's like should I put some more pictures? So like say like for your face recognition, every filter will detect some information about your ear, nose, eye, lips, and that's how they are able to process the information. And in the whole processing, when it comes to softmax layers, it detects whether it's a cat or dog or not. And when I talked about earlier transfer learning, right? So transfer learning is another technique, which what it does is, because training of this kind of model, especially this kind of deep neural net, you need more than millions of images, and which takes like a month to train. It's not for everybody to can go and easily train the whole thing. So what the latest tech development happened is something called transfer learning. So in transfer learning, you take this thing and basically you cut down here, okay, and use till here, and then use whatever existing feature you have, and then you can augment new images, and it will able to classify. Yeah. Anybody else? Yeah.
So, can you clarify how do you mention that this is going to change the marketing? Because currently the way in which you explained it, it's not based on real-time data, right? So these are the pictures that has already been posted. So by the time I post it, and then my mood could have changed, I'm probably thinking about something else.
No, this is